Hi, I will teach you how to use grep like an engineer. This utility will improve your debugging and scripting skills by allowing you to search for text patterns in menu files and directories with ease. I will cover several options for calling grep, then show you the useful flags, and then cover some usage examples and several ways of using grep in a script. I will also show you the tricks of using grep with VS Code. When we use grep, the input data may come from standard input or from the file system. Let's discuss the three usage variations. Option 1. Grep searches by taking input from standard input. This allows us to pipe input into grep. For example, here I am using the cat utility to output the contents of the file and pipe that into the standard input of grep. We match the word serial in this file. Another example is getting your computer's IP information and searching for strings in it. For example, here I'm looking for all the interfaces that are up. The loopback and eat0. Option 2. Grep searches all content in current directory. We'll use the asterisk to match everything in the current directory. For example, in this form, grep will search all files and directories for the matching substring. Also notice that grep is displaying messages for directories. This is because the asterisk will match everything in the current directory. This means that even directories are passed into grep, but a directory itself cannot be searched, so grep will display a message for each directory it sees. I will later show you how to ignore this message. We can also replace the asterisk with a file name to search through a particular set of files. For example, we can even combine file names and the asterisk to match multiple files. For example, matching the file name starting with SSH. Another example would be matching all C source files ending in .c. I want to clarify that the asterisk used in these examples for option 2 is part of the shell file system expansion and not part of grep regular expressions. We'll get there soon and get to the bottom of what the asterisk really is in the shell and within grep. For now, I'd just like to say that the shell is actually turning this command, grep searching for the word search in files ending in .c, into the following. Star.c was expanded into all the file names ending in .c by the shell itself and not by grep. Option 3, grep searches through files and directories recursively. The -r option tells grep to search all files under each directory recursively. This is my most used grep form as it allows me to search for a string through the entire repo. Once we learn some more optional flags, we'll build this into a powerful command. For example, we match the word search in Unix GTK font.c and in the Windows directory window.c, winconfig.c, and so on. Let's cover some useful grep flags. If we want to match multiple strings, we will use the -e option with each substring. For example, -e search and -e serial will match both search and serial. We can ignore the lower and upper case when searching for a string by using -i. For example, serial all lowercase, serial with the all uppercase or with a capital letter S. We can print the line number in the file which match the expression by using -n. For example, adding -n. We now have the line number where the match was located in. We can invert the match with -v. This will print non-matching lines. For example, we have a file containing animal types and their names, such as cat, dog, etc. If we want to get all animals except for cats, we can search for cats and then invert the search. For example, searching for cat and inverting the search, we'll get dog, fish, parrot, hedgehog. To match whole words, we use -w. This option may help you by removing extra matches if you know the exact word you're looking for in the repo. An example may be if you're trying to find cereal and want to avoid serialize or other versions of cereal. For example, running without -w, we get cereal, but we also get deserialize and deserialize over here and serialize. Let's add -w. We now only get cereal and separated by a white space or with a dash or with a comma. To only print the file names where a match is located, use -l. For example, -l. We now get all of the files where cereal is located in. To only print the file names where no matches are found, use -l. This will invert the search. These are all the files that do not contain cereal inside of them. To suppress error messages about non-existent or unreadable files, use -s. For example, test is a directory. It is an error message. Let's get rid of it by adding -s. And now the output is clean. To print some lines after a match was detected for better context, use -a with the number of lines you would like printed, and emphasis on after a match was found. For example, here we are finding cereal and printing 3 lines of context afterwards. We can also print some lines before a match was detected for better context by using -b and the number of lines to print. For example, -b4, and now we are finding cereal and printing 4 lines of context before the match. To print some lines before and after a match was detected for better context, use -c. So let's try it with 5 lines and -c. We are matching cereal, printing 5 lines before, 5 lines after. And I prefer using -c3 as it gives me enough context to debug and it gives me context before and after. Skip searching through certain files whose name matches glob by using --exclude equals glob. And note, this does not apply to directories but only to files. An example will be to ignore the files that deal with SSH. For example, if we search for cereal, there are lots of files that contain SSH in them. Let's exclude them. Now we are finding all of the files except for SSH files. To only search for certain files whose name matches glob, use --include. And again, please note that this is for files and not directories. And this time, let's search for all of the files that have SSH in their name. So let's replace exclude with include. And make sure you put the asterisk on both sides if you want the name to just be in here. In my case, this means starting with SSH. We can also use this command to only search through the source and header files of a project, thus avoiding all documentation configuration files. An example may be to only search in the .c and .h files. For example, now we are matching the .c source files and .h files. To exclude directories, we will use -- exclude dir. Our example will be to skip the dock and Windows directories. For example, simply searching for all instances of COM, we see there are some in Windows and some in a doc file. Now let's go ahead and exclude them. We have now excluded them. Also notice up above, we have .123.git and .hidden. Specifically, I want you to focus on .git, which will be in basically every repo if it's on GitHub. And you might not want to be searching through the .git repo because it's not in the source or header files of your project. So let's figure out a way of how we can exclude this directory. To do this, we must match the dot in the directory name while at the same time avoiding matching the current directory because its name is also dot. For example, the current directory is a dot directory. So if we do exclude there dot asterisk, we will obviously exclude the .git directory, but we'll also exclude the current directory. Nothing will be printed. A possible solution will be to match the substring .git asterisk. For example, right here, exclude their .git. So we have now excluded the .git directory, but we still have the .hidden and .123 directories. And we want our command to work for all cases, for all hidden files. We can match the following: dot, A through Z, and A through Z uppercase, and 0 through 9 asterisk. This will match any hidden directory that starts with a number or letter. For example, exclude the following. Let's try this. This worked, and we are no longer matching the .hidden or .123 or .git directories by matching for any character or number fall after the dot. We can simplify this some more by using allnum, which is just a set of all the numbers and letters. We will touch on this a bit more later. For now, an example usage will be exclude their allnum. And this also works as intended. The .git and .hidden directories are no longer being found. To search for patterns located in a file, we use the -f flag, followed by the name of the file. Multiple patterns can be supplied in the file. Put the search patterns on separate lines and ensure you use the Linux line feed \n and not the Windows version. For example, my file search_for.txt contains communication and serialize. To search for this, I will do -f search_for.txt. And we are now finding all of the instances of communication and serialize in our repo, such as here and here. Sometimes grep may not display things correctly. We can get rid of the coloring with this option, --color equals never. For example, everything is red right now, where a match is located. And if we add color equals never, everything should be one color now. Now let's review the basics of regular expressions. These will allow us to use special characters to define a search pattern. When we get there, we will use the -e option to tell grep that our search string is an extended regular expression. Before we jump into the regular expressions, we need to understand that the shell itself has characters with special meanings called meta characters. Some of these meta characters have similar meanings to how they work in grep. This can be an area of confusion, so we're going to cover this first and learn how to work around this. Here's a list of some of the bash meta characters. So there are things like the pipe, the ampersand, parentheses, and then redirection, the question mark. This has pretty similar meaning as to what grep has, whereas the asterisk will actually have a different meaning, slightly different, and in brackets have a pretty similar meaning to what's in grep. And then we have some underside that shows control operators. And then we have some more meta characters such as the pipe, ampersand, redirection, etc. So there's quite a few in this shell actually. We want you to be careful when dealing with grep and these characters. I'll cover some basic usage of these. For example, running this in our test directory. Here, we matched all of these files, and this was all done by the shell. The shell took M, is matching for M, the first letter, followed by A through Z, right here, followed by A through Z. So the second letter can be any letter A through Z, and then the asterisk matches the rest, anything afterwards. We can also use the echo utility to see exactly what the shell called our command with. So echo shell actually called, and then this right here, and we can see that the shell expands this into main.c, main.text, etc. So the shell will expand this, it's called file name expansion, and call the utility with these arguments. As you can imagine, we don't want to let the shell conflict with our grep regular expressions. We'll later cover some of the differences between the meta characters, like the asterisk when used by the shell and when used within grep. What we will do when we use grep is surround the regular expressions in quotes. For example, if we try our last example again, but in quotes this time, so we can see it's not matching any file because there's no file that's literally named M A through Z asterisk. And let's use the echo command to see what it was called with. Echo this right here. The shell actually called M A through Z. So now the shell did not expand this because we use quotes. So we can use quotes to pass in the literal string into grep is what I'm trying to get at. And we'll let grep use its own regular expression capabilities to perform searching. The first regular expression we will cover is the one that matches a single character. This is the period. It will match any single character. Fortunately, the period is not a meta character of the shell, so surrounding it within quotes is not required but optional. For example, grep for serial.I. Let's go back to our repo. So here we match serial bracket I, serial underscore I. So the bracket and then the underscore are being matched with the I, with the dot, because the dot can match any character. And we can also surround this in quotes. And it shouldn't make a difference. If we want to literally match the dot character in a string, we need to use quotation marks and a backslash. For example, we want to match red dot. Let's try this first. And I think this will be in this one. So red dot, red, and the dot matched the white space. Red dot, reddish, red dot, required. Now if we want to just match red dot, again we need to use the backslash, but because the backslash is a special meta character in the shell, we need to surround it in quotes. And now we are matching red dot. If we want to match any character that's in a set of characters, we place them into brackets. For example, bracket 2EI will match either 2 or the letters E or I. So here we match searching, searched, search 234, etc. Let's do another example to see how shell expansion can give really weird results. So in this example, ls will list the contents of this directory. We'll grep for 234.abchijkm in the brackets and then print the line number. So what this is showing me is we have the files tree234.c and .h in this directory, and this is working as expected. Now let's try without the quotes. So let's go ahead and remove the quotes. So the results are slightly different or very different. Now we found on line 2 tree234.c and tree234 parentheses c. This isn't what we expected, so what happened? Well, the ls command isn't even doing anything at this point. Let's just run the grep command. So in other words, let's go ahead and get rid of the ls command. Same exact thing. Let's also take a look at what the shell expansion will be. So by this let's leave the -n. Let's just replace this with echo. tree234.c, tree234.h. So what actually happened? Grep was called like this. So the shell called grep with these inputs. Even though we typed in this is what we actually got. And now we understand why grep was searching for tree234.c and tree234. The dot can match anything, including the parentheses, and then c. So I hope this example helped you to remember about parentheses. Let's review one more thing about shell expansion. If there are no files directories that can expand the expression, then the expression is passed in as is. For example, let's add ABC to the end of the expression to make a non-existent file folder. For example, let's just go back to our echo example, which was doing this, but add in ABC. Now we actually got in the literal string that we passed in. In this case, we see that the shell has nothing to expand, so it would pass the correct string into grep. I recommend using quotes and understanding how the shell works so you can avoid mistakes. Hopefully you got the point that shell expansion can lead to unexpected outcomes and we need to use quotes. The inverse of this would be to match any character not in the brackets but using the caret. And it has to be placed in the very beginning. This will match any character except for 2EI. For example, search, and then you not match anything you not match the next character if it's a 2E or I. So now we match search test because T is not in their list, and search parentheses. So let's go ahead and get rid of search test. We'll just add a T to the end. Now there shouldn't be any more search tests because we're not matching the T. We inverted the search by using the caret. We can also put a range of characters into the brackets to match a large set of characters. For example, A through D, they should match letters A, B, C, or D. However, what this actually matches depends on the locale being used. We'll briefly touch on locales later. For now, let's go ahead and try this example. Search, and then A through Z. So now we're matching searching, matching the I, because I is between A and Z, searched, search test, searching, etc. To match the beginning of a line, we use the caret. So the caret has two meanings. You can invert the search when used in brackets, such as these right here, right here. But if we put it at the beginning and not in brackets, it will match the beginning of a line. For example, command is now at the beginning of the line because we used the caret. And notice that I'm surrounding it with quotes. To match the end of a line, we use the $sign. So now serial appears at the very end. And then these are useful if you expect the text to be the end, beginning, or end of a line. Let's learn the limitations of quotation marks and how to escape certain meta characters. A working example is grep SSH1. So now we've matched SSH-1. Now let's search for -1 in our repo. We already know it's there since SSH-1 is in our repo. So let's go ahead and try this. Let's just get rid of SSH. We're matching build source. Seems weird. Let's go and figure out what's going on. Let's also add, let's try it recursively. Yeah, we're matching some really weird stuff when we try to do it recursively. What is going on? Let's try to use quotation marks. And let's go back to searching only in current directory because that was way too much output over here when we did it recursively. So we use quotation marks. There's no difference though. Build source is being matched, and we want to find -1 or -1, how you want to call it. Let's use echo to analyze what is happening. So echo -1 star, and looks like we are matching a bunch of files in this directory. That's the star. The star is matching all of this, but we have -1. So this actually looks pretty good. Let's try to surround it in quotes to see if anything will change. Again, same thing, echo -1. We have our -1 right here, so it's actually looking good. Let's try the -1-r. So it's echoing exactly what we passed in. Let's try quotes. Same thing, it's all looking good. So the quotation marks around -1 do not do anything. So what's going on? Well, because the minus is a meta character inside of grep and not a part of the shell, grep never sees our quotation marks. So that's why the quotation marks, whether we put them or not, doesn't matter. The minus is not a bash meta character, so it doesn't matter if we put quotes or not around it. So what's going on with grepping for -1 and we get all this weird stuff? Well, let's search for -v in the repo since we know it should be in here. So let's go ahead and try this. We're searching for -v and looks like it didn't work, and then we instead printed the grep version 3.7. So what happened? Grep printed its version exited. Let's try this. Grep-v. So again, prints the version and exits. And we can even surround the -v in quotation marks. Same thing, no difference. Since the minus is a meta character, must be escaped with the backslash. So I hope you recognize what's happening here. When we did the previous example, such as this one, or actually grep -1 star, the minus is a grep meta character, and grep does not know that it needs to match -1. It's treating it as an input, like a control argument. So it must be escaped with a backslash. And in order to use the backslash, we need to surround it in quotes, so that the shell doesn't mess our input up. Star. Now we are able to match -1. Now we can also use that grep for -v, but we have to use the quotes and the backslash. Let's try this. And again, we're matching -v, Control-Shift-V. And let's analyze the backslash escape mechanism. Echo, in quotes, \-1. So here we got the backslash. This means it's actually being passed into grep when we surround it with quotes and pass it into grep. So grep will receive the backslash from the shell and properly search for an intended string. So I hope this reminds you that whenever you need to search for -1 inside of grep, you don't get this kind of bad output, but you go ahead and surround it in quotes and a backslash, and you search for whatever you intended. Now let's review how to handle repetition. Repetition allows us to match a set of characters multiple times. The man pages for grep shows the following. Let's jump through these over here. We can use the question mark to match variations in a search string. The question mark means the preceding item is optional and matched at most once. For example, some words may be spelled differently by different people, such as color or skillful or license. Here's how I would detect these words. We'll detect color with or without the U by using the question mark. So the U is optional due to the question mark, and we'll use -e to mean it is an extended regular expression. Let's go to our test repo. Test folder. So we've matched color without the U and color with the U here. Now we can detect skillful with 1 or 2 L's, but making the second L optional. So the question mark makes the second L optional. Skillful with 1 L and skillful with 2 L's. Now for license, you can do this. So making the C and the S both optional. But notice the incorrect spelling without a C or an S was also matched, but we do want to match either the C or the S. We can instead just use a bracket. The brackets should either match the C or the S, such as this. Also notice that the question mark in the bash meta characters actually matches any single character. It's just another difference in meaning between bash and grep meta characters. I think I made a mistake earlier when I said they're similar. These are very different meanings. In bash, the question mark means it will match any single character in a file name or pattern. So this is more similar to the dot or the period in grep, whereas in grep, the question mark means the preceding character is optional. So these are very different meanings. Now let's review the asterisk. Notice that in shell meta characters, the asterisk matches 0 or more characters in file name expansion. The asterisk matches any sequence of characters, including none, in a file name or pattern. So this is why we were able to match the end of a file name being .text or .c or .h using the star before it. But in grep, regular expression, the asterisk means the preceding item will be matched 0 or more times. So again, this is a pretty different meaning than how it's used in shell file name expansion. Let's try a few examples using the asterisk. Let's compare the shell file name expansion with grep. So first we'll do, so we've been searching for .text, file names ending in .text, and we matched the entire file name in this case. This expands the entire file name and passes it into the ls utility. We can also use echo to see how the shell calls us. And as expected, the first file, asterisk example.txt, curly braces example, invert example, IP address example, etc. However, in grep, we see that the match string is much smaller. So let's go ahead and try this. ls-l. So grep literally matched .text in all of the files and directories in our document. I just found the files that end in .text. Whereas over here, star.text matched the entire string. And but for grep, it matched only this part. So why is grep not matching the entire name? Well, again, because the asterisk only matches the preceding item, but in our case, there is no preceding item, so it didn't match anything. Let's match both color and color using the asterisk. So this will be another example to help understand the difference. And what's happening here is the asterisk is making the U matches the U 0 or more times. So in color, it matched the U 0 times. It's not because it's not there, but over here I was able to match it. So going back, what's the difference between the asterisk and the question mark? The question mark means the preceding item is optional and matched at most once, whereas the asterisk means that it can be matched. It's optional. Optional means matched 0 times or more times. So the only difference is the question mark matches things once, 0 or 1 time, while the asterisk matches things 0 or many times. 0, 1, 2, continue on forever. So again, here is another example that I had. Colors, the spelling is wrong, but because the asterisk matches the U multiple times, or it could, we were able to match colors with multiple hues. Let's do another example. So right here I have high, and we're matching the I 0 or more times. So we're able to match the H, only the H, because there's no I. I is matched 0 times in this example. In this example, we match the I twice, and in this example many times. Let's do a better example that will give you ideas on how to apply the asterisk to find various functions and variables in a repo. So if we look for grep-sum function dot star, and remember the dot means we can match any character. and then continue on with the parentheses. This will help us to find the name. If we know the starting name of a function, we'll find a function because it has to end with the parentheses. We have to use the backslash as the parentheses has a special meaning in a grep regular expression. And the backslash instructs grep to treat the parentheses as a normal character. Our regular expression therefore means search for some function followed by any amounts of characters until we reach the last opening parentheses. And notice I say the last on this line. And note grep doesn't stop when it finds the first opening parentheses, but rather the last opening parentheses on the line. And let's apply this concept to our example repo. So let's go open it up. So we're going to be searching for SSH functions. Okay, so we found SSH, one connection new, and the parentheses, nothing special here, or so it looks. Oh, look at this one, the packet protocol layer. Let's go up a bit higher. SSH binary source, some kind of binary sync. So we can basically find functions pretty easily like this. So here's a long string. And notice this example right here, even though we found SSH and the parentheses, we actually continued on until we found this parentheses, the last one. grep will find the last parentheses because the asterisk is actually matching all of this. The plus means the preceding item will be matched one or more times. This is similar to the asterisk, but the plus requires there to be at least one match. Our example will be learning how to match an IP address. 127.0.50.2, for example. Let's view this as 4 sets of digits separated by 3 periods. Let's start by searching for all numbers in our test directory. So let's come back here. So searching for all numbers, we have the time, we have different IP addresses, and notice I have a lot of valid and invalid forms because we're going to make this perfect. Now let's match the period. So we'll add 0 through 9 and then backslash dot because we want to match the period and not any character. Okay, getting closer. Now we're matching an IP address and the dot. Now let's replicate this expression to match the digits in the second octet. So we're matching 0 through 9 dot 0 through 9 dot. We'll just continue working our way one at a time. Okay, now this is starting to look more like IP addresses. No more random times, just numbers and dots, IP addresses. And notice we still need to match, like I said, the 12 or 127. We matched the 7 here, the 7, but we need to match the 12 also. It's part of the IP address. Let's replicate the expression one more time to match the digits in the third octet. So let's just add another octet. Okay, now we're matching invalid IP addresses, but at least we're getting the first octet, the second octet, and the third octet. At this point, we're no longer matching our correct IP addresses. That's because there are 2 digits in the third octet, but we only match one of the digits. Let's add the plus to match one or more of the digits in each octet. So again, as you remember, the plus means from where's our table. The preceding item will be matched one or more times. An IP address has to have at least one character in each, or one digit in each octet. So we're going to add the plus right here. So 0 through 9 can be matched one or more times. Let's take a look. So plus, plus, and plus. Okay, that's better, but now we're matching lots of invalid IP addresses, but at least we're matching something. But now we got 127. So before we were only matching the 7, now we're matching 127. So that's good. Let's finish the regular expression by matching the fourth octet. So in this case, we match the first, second, and third octet. So here's the fourth octet. We need to match it. So we'll just add 0 through 9 at the end. Excellent. Now we have the first octet, second, third, and fourth octet being matched. And now we now have a regular expression that will work for most scenarios where we match IP addresses. And then an IP address can only be between 0 and 255 in each octet, even though we're not checking for that. So far, in most scenarios, we'll grab and find the IP address that we're looking for. So yeah, we're matching lots of invalid forms such as .2000. And in most cases, this will work. When we'll get there, we're gonna fix this and make it perfect. But first, we have to learn about curly braces. We can use the curly braces to tell grep the number of times to match something. For example, in this form, the preceding item is matched exactly n times. In this form with a comma, the preceding item is matched n or more times. So this is similar to the plus. If n equals 1, of course, the preceding item is matched at most m times. And if m is equal to 1, this is similar to the question mark. And through m, the preceding item is matched at least n times, but not more than m times. Notice that we can construct a plus and asterisk with these curly braces. And also the question mark. Grep -e how one LED, let's try this, is equivalent to how plus, in this case the 1 comma is equivalent to the plus sign. And then 0 comma is equivalent to the asterisk. And then let's match the W exactly 3 times. Let's see if I actually have an example of this. Yep, I do. So we were able to howl, the wolf howled, the wolves howled, lots of W's. And if we were to run this one, again, exact same output because these are equivalent. Let's run these 2 examples also. In this case, there is no W, but the 0 means it can be matched 0 times, so the W is matched 0 times. And if we use the asterisk, we should get the exact same thing. Let's match the W exactly 3 times. Perfect. Let's match the W 3 or less times using this form. So 0 times, 3 times, and 1 time. And let's match it 1, 1, 3 times. Perfect. Let's also clean up our IP address commands. Each octet can have 1 to 3 digits. Let's ensure only 1 to 3 digits are matched. So I want to get rid of this invalid form where there's 4 digits in an address. So using braces will make sure the match can be between 1 and 3. So we're replacing the plus with 1 and 3, 1 to 3. Let's try this. Perfect. Every scenario is now between 1 and 3 digits in each octet. And then notice that if there are 4 plus digits in the first or last octet, we still match 3 digits and an invalid IP address format gets matched. In this case, right over here, even though we matched 402, the 0 is not matched, but it happens to be in the end. And same for this example. If the first digit is in the beginning of the string, it's not matched, but it's there. We've already learned about inversion, so let's try to match for something that is not a digit at the very beginning and end of the IP address. Let's focus on matching something that is not a digit at the very beginning of the line. So invert 0 through 9 means match anything that is not a digit and then afterwards match 0 through 9 1 to 3 times. Let's try this. So this case it's gone now. The problem with this is that valid IP addresses that occur at the beginning of a line are not matched. For example, we had this case, it was an IP address that was at the beginning of the line, and it's no longer being matched. So we need to either match the beginning of a line or any digit besides a number. Now is a good time to learn how to use parentheses and the OR operator in grep. The pipe character is treated as OR. Let's try adding this. This right here, the caret means the beginning of a line, and then the pipe means OR. Match something that is not 0 through 9. This will translate as match the beginning of a line or any character that is not 0 through 9. Let's add this to our expression. So here is where I've added it. Let's try to run this. Now we are matching the beginning of a line. Excellent. And this scenario is no longer happening here. Now let's add the same logic to the end of a regular expression. Don't match any character that is a digit, or match the end of the line, the $sign. We've added this right here. So we are trying to avoid this scenario right here. And their grep is having trouble with outputting the information that came out because of Windows line feeds. So we'll add -- color equals never. And now we're seeing more valid IP addresses, but we still have a few invalid ones that we'll need to work on. Now let's figure out how to only match numbers between 0 and 255. So the reason why this is invalid is because it's .300, and that is outside of the range of valid IP addresses, which can only be between 0 and 255 for each octet. But so far, we've made the form of an IP address that is 3 octets, 3 digits in each of the 4 octets, or up to 3 digits. Perfect. This has 3 digits, this has 1 digit, 2 digits. So we're matching the form correctly. We just need to work on the 0 to 255. Let's match the first digit between 0 and 2 and the next 2 digits between 0 and 9. So we're going from here. So we're matching 0 through 9 1 to 3 times. That is 1 digit or 2 digits or 3 digits. To here, match 0 to 2 and make it optional, because if, as in this case, this can be 0 or 9. So make the first digit optional and then match 0 through 9 1 to 2 times. So the final expression will be this right here. And notice all of our IP addresses are now valid, valid, valid. Yep. Even these ones .088. You never know what the user is going to give you for the format. It might look something like .0.50, or it might look something like .020.3.40. You never know, but this has 3 digits and it's a valid form. And this is probably the best grep regular expression for matching IP addresses. In engineering, you must understand the different edge cases, the valid and invalid forms, and ensure your solution works in all scenarios. We've now created a way of matching an IP address and figured out how to test for edge cases and invalid forms and handle them. And testing, finding bugs, and fixing one thing at a time is a skill you need to master by practicing and understanding the capabilities of the system. Go through this process and you'll create the best of the best. Let's quickly review locales and matching a range of characters. To match A through D, we can use the brackets and A through D. But how does grep know what type of alphabet to use? For example, in an Estonian alphabet, the order is A to Z, and then we have T, U, V, etc. If you wanted to match all letters ended A through Z, you would not match the letter T and the rest of the alphabet. That is because Z is right here, and the rest of the alphabet, such as T, goes afterwards. And then here's a real issue on this topic. So we had someone that was trying to echo T and grabbing A through Z, but there was no match. And they later discovered that their locale was set up to the Estonian locale, and their alphabet was A through Z, followed by T, U, V, W, etc. And due to this, they were not matching the letter T. So this brings us to locale. It is a set of environment variables that define your language and character encoding. To see how your locale is defined, use the locale command. So here we have the language is set up to be c.utf8, and we also have lc_all not defined. To change the locale in the current shell, export lc_all equals. So in this case, lc_all will not be defined. This will grep to use what is defined in lang. So when this is not defined, grep will use whatever was defined in the language variable. And if you need to change it to the C locale, this is one way to do it. Export lc. So now we've changed this, and this will be just per my shell session. So you have to do this every time you start a new shell session. So I'll go back to the empty one, and using c.utf8 is good enough for me. And most likely you won't have any locale problems, but if your system is not set up for English, this is one thing to verify. So if you're in a different country and you have different languages, just go ahead and verify what your locale is set up to, just so you don't get unexpected results. We'll now look at how grep can be used inside a shell script. Example 1, we'll execute the IP command and search for all the interfaces that are up. Let's go ahead and try this out. Here is my bash shell script that will print all the IP addresses and search for all the interfaces that are up. And it's located right here. Perfect, we found the loopback interface and each 0. Next, we'll refine our search to ignore the loopback interface. So let's add the following, searching for loopback, which is located right here, and use -v to invert the search so that we can ignore it. Perfect, now we have all the interfaces that are up except for the loopback interface. Finally, let's learn how to save this output to a variable. And then we have two options. The first option is using backticks. We execute our entire command or expression, and we put it around backticks and save it to a variable. And then let's use echo to display the contents of this argument or this variable to see if it worked or not. So let's save that. And perfect, the results are exactly as expected. The second option is to use the $ and parentheses wrapped around our expression, and again save it to a variable and print its contents. Let's execute this, and it works exactly as expected. For example 2, we'll curl a web page from the Linux source code. So let's go ahead and do that. And before we do it, here's the web page we're looking at. And it contains a bunch of .c source files, some directories, and some kconfig files. And we'll just curl the web page. Perfect. Afterwards, let's save this output and use the echo utility to grep for strings inside of here. So again, we'll wrap our expression curl and the web page URL with the $ and parentheses, and I use the echo command to display the contents of this variable. And perfect, we got the same exact results. Notice that I wrote double quotes are required to preserve new line characters. So if we were to get rid of these double quotes, we will actually lose all of our new line characters. So the grep won't really work on this anymore because it's just one long line of info or data. So let's use double quotes to preserve new line characters. The next part will be trying to find kconfig lines from this entire web page. And by this, I mean here in the web page, we see kconfig.freezer, kconfig.hz, kconfig, etc. Let's try to find all of these files. And let's find the URL to these files. So to do this, we will echo our web page that we just saved, and we'll grep for kconfig inside of it, and then we'll echo all of the kconfig info that we found, all of the lines containing kconfig. Let's try this. Okay, looks like we found kconfig here. Here's another one, and another one right here, And notice this is starting to look like the URL to this kconfig.freezer because it's an href, Linux, v6 416, source, kernel, etc. But let's clean this up so that we can get rid of some of these tab index and these ones. All we want is the href. So to do this, we will grep for href because we want to match all of the href. And we will also grep for tab index, but use -v to invert the search so that we can ignore it. I want to ignore this tab index line. I only want this one right here. And let's echo only the kconfig hrefs. And this is looking good. href should kconfig.freezer.hz, kconfig.kexec, etc. So going through this process of grabbing an entire web page and then slowly refining your search will allow you to automate anything you need to automate and search for whatever what you're searching for. Hope this example helps. Let's now review how we can use grep inside of Visual Studio Code. So first, let's open up VS Code. Open our repo in VS Code. So here's my repo, put it already open in the workspace. And then open a terminal. So select terminal, new terminal, and finally run WSL. And let's try a few examples. Let's search for the word serial. Notice that whenever we find serial, we can now hover our cursor over the file path and click open file in editor. And we'll be taken exactly to where the match was located in. Let's do another example. Right over here, again, open file in editor. This will help you debug very fast and very efficiently. And when searching, ensure that you're in the base directory of the repo, same directory that is open up in VS Code, right here, PuTTY, in order for this feature to work. So by this, if you go into a nested directory such as Unix, for my example, and again, search for serial, we're no longer able to go to this directory. What we need to do instead is go back to our base directory and type in the path to our nested directory where we want the search to begin in. And then click enter. Now we are searching only in the Unix directory. And we can again put our cursor over here and find the exact spot where this was located. And thank you for watching, and I hope you guys use grep for debugging and searching, and make sure to practice what I showed you. Good luck.